Out in the vast expanse of our solar system, far beyond Saturn, lies a giant. This blue giant is Neptune, the eighth and farthest planet from the Sun. Invisible to the naked eye, Neptune remained hidden from humanity for millennia. Its discovery marked a turning point in astronomy. We realized our solar system held even more wonders than we could see. Neptune is a gas giant, much like Jupiter and Saturn. Its atmosphere is a swirling canvas of blue and teal, colored by methane gas. This gas absorbs red light from the sun, reflecting back the blue hues we observe. Neptune's size is impressive. You could fit nearly 60 Earths inside it. This distant world is a realm of extremes. It boasts the strongest winds in the solar system, with speeds exceeding 1,200 miles per hour. Its temperatures are frigid, dipping hundreds of degrees below zero, and its storms are colossal, raging for months or even years. Neptune is a mysterious world, still shrouded in secrets. But with each passing year, our robotic emissaries send back more data, slowly unraveling the mysteries of this blue giant. When we think of the coldest planet in our solar system, Neptune often comes to mind. It's incredibly far from the Sun, receiving only a tiny fraction of the warmth we feel on Earth. And indeed, Neptune is incredibly cold, with temperatures plummeting to minus 392 degrees Fahrenheit, or minus 200 degrees Celsius. But it's not the coldest. That title belongs to Uranus, Neptune's slightly closer neighbor. While Uranus and Neptune are similar in many ways, Uranus holds the record for the coldest temperature ever measured in our solar system. This temperature, a bone-chilling minus 371 degrees Fahrenheit, or minus 224 degrees Celsius, is thought to be due to Uranus's unique tilt. Why is Uranus colder, even though it's closer to the Sun? The answer likely lies in its history. Billions of years ago, Uranus may have experienced a massive collision. This collision could have knocked the planet on its side. As a result, Uranus rotates on its side, with its poles facing the Sun for long periods. This unusual orientation might have disrupted Uranus's internal heat source, making it colder than expected. So, while Neptune is incredibly cold, it's Uranus that holds the crown for the most frigid planet in our solar system. Neptune's discovery is a testament to the power of mathematics and human ingenuity. Unlike other planets discovered through direct observation, Neptune was first predicted to exist. Astronomers noticed something peculiar about Uranus's orbit. It wasn't quite moving as expected based on Newton's laws of gravity. The irregularities in Uranus's orbit suggested an unseen force was at play. A young French mathematician named Urbain Le Verrier took on the challenge of explaining these discrepancies. He meticulously calculated the position and mass of an unknown planet that could be influencing Uranus's path. In 1846, Le Verrier shared his calculations with Johann Galle, an astronomer at the Berlin Observatory. Galle pointed his telescope towards the predicted location, and there it was. Neptune, exactly where Le Verrier said it would be. The discovery of Neptune sent shockwaves through the scientific community. It proved that we could discover celestial objects not by chance observation, but through the power of mathematics. This triumph of science ushered in a new era of astronomical exploration. Neptune is a distant world, orbiting the Sun at an average distance of 2.8 billion miles. That's about 30 times farther from the Sun than Earth. It takes light from the Sun over 4 hours to reach Neptune. Imagine sending a message to someone on Neptune. It would take 4 hours for your message to arrive and another 4 hours for their response. This distant giant is not alone in its corner of the solar system. Neptune has 14 known moons, each with its own story to tell. The largest and most intriguing of these is Triton. Triton is unique among all large moons in our solar system. It orbits Neptune in the opposite direction of Neptune's rotation. This retrograde orbit suggests that Triton wasn't always a part of Neptune's family. It was likely captured from the Kuiper belt, a region beyond Neptune containing icy remnants from the early solar system. Triton is a geologically active world with nitrogen geysers erupting from its surface. It's a captivating moon, providing scientists with clues about the early solar system and the dynamics of planetary capture. Deep within Neptune's atmosphere, something extraordinary is happening. The intense pressure and heat, combined with the presence of methane, create the perfect conditions for the formation of diamonds. Yes, you read that right, diamonds. Scientists believe that deep inside Neptune, it rains diamonds. These diamonds, formed in the planet's hot, pressurized interior, slowly fall towards the core like glittering hailstones. This phenomenon, while still theoretical, is supported by laboratory experiments replicating Neptune's extreme conditions. Imagine a sky filled with shimmering diamonds, raining down on a sea of liquid methane. It's a scene straight out of science fiction, but on Neptune, it might be a reality. This diamond rain is just one of the many fascinating and bizarre phenomena thought to occur within this enigmatic planet. Neptune is a stormy place. In fact, it's home to the fastest winds in the solar system. These winds, whipped up by the planet's internal heat and rapid rotation, can reach speeds of over 1,200 miles per hour. That's twice the speed of sound on Earth. One of the most striking features observed on Neptune was the Great Dark Spot. This massive storm, first observed by Voyager 2 in 1989, was large enough to contain the entire Earth. The Great Dark Spot was a swirling vortex of dark clouds, similar to Jupiter's Great Red Spot. However, unlike Jupiter's long-lived storm, the Great Dark Spot was relatively short-lived. When the Hubble Space Telescope observed Neptune in 1994, the Great Dark Spot had vanished. This disappearance highlighted the dynamic nature of Neptune's atmosphere, where storms can form and dissipate on timescales much shorter than on Jupiter. If we ever dreamed of setting foot on Neptune, we'd be in for a rude awakening. Unlike Earth, Neptune doesn't have a solid surface to stand on. It's a gas giant, meaning it's mostly composed of swirling gases and liquids. As you descended through Neptune's atmosphere, you wouldn't encounter solid ground. Instead, you'd experience increasing pressure and heat. The atmosphere would become denser, eventually transitioning into a hot, slushy mix of water, methane, and ammonia. This exotic mix, far from being a hospitable landing site, would be incredibly hostile to any known life form. The crushing pressure, scorching temperatures, and toxic gases would make it impossible for any spacecraft, let alone humans, to survive. While we can observe Neptune from afar and study it with telescopes and probes, landing on this gas giant is simply impossible. Neptune, the blue giant of our solar system, remains a world of mysteries. Despite decades of observation and study, this distant planet continues to intrigue and puzzle scientists. Its unusual magnetic field, tilted at a strange angle compared to its rotation axis, remains unexplained. The exact mechanisms driving its powerful storms and generating its internal heat are still being investigated. And what of the diamond rain? While theoretically plausible, we have yet to observe this phenomenon directly. Future missions to Neptune, equipped with more advanced instruments, might one day be able to confirm the existence of these glittering showers. Neptune's significance extends beyond its own enigmatic nature. By studying this distant world, we gain insights into the formation and evolution of our solar system. We learn about the processes that shape giant planets and the complex interactions between planets and their moons. Neptune, a world of extremes and mysteries, continues to beckon us to explore the unknown reaches of our cosmic neighborhood.